For this lecture, we're going to look at the derivative of some log functions first, and then later on it's going to be derivative of exponential functions. So we start with log. Log functions can be written like this. So log stand for logarithms. It's log functions of x. So x is the input to the log with base e. So now e here is a constant. Uh, if you use your calculator to show the values of e, it's approximately 2.71. But don't use 2.71 because then it's not accurate. Just use the e in the calculator. We can also denote log base e with these notations ln of x. But remember, the input to the log has to be positive number, so there's no log of negative number. Okay. Now what we want is we want to study the differentiations or the derivative of ln of x. It turns out derivative of ln of x equal to 1 over x. Now we have to remember this so we can apply in the problems. So let's see how can we use this. So let's look at the first problem. So y is equal to 5 ln of x. We want to find the derivative of y. So what we do is you see that 5 is a constant multiplied with some function of x. So 5, we don't do anything. And then we go ahead and differentiate ln of x. And this equal to 1 over x. Okay. So the answer is 5 multiplied with 1 over x, or 5 over x. Okay. Let's move on to part B. Okay. So for part B, you see that y is equal to ln of x divided by x squared. And again, we want to find the derivative. Okay. So if you think of these functions, you can see that this is a division. So we're going to use quotient rule. Okay. Okay. So the function on the top, this is the high term. The function on the bottom, this is the whole term. Okay. So quotient rule. So whole square, whole dip high minus high dip whole over whole. So x square, it's the whole. Differentiate high, so differentiate ln of x minus whole dip high minus high, it's ln of x. Differentiate whole, differentiate x square, you get 2x over whole, which is x squared to the power of 2. Now you can see that we need to know what is the derivative of ln of x, which we just studied. It's equal to 1 over x. Okay. So if we put everything together, we see that 1 over x here cancel with 1 of the x. So we get x minus 2x multiplied with ln of x over x to the power of 4. We can simplify this further because all the terms had at least 1x, so we cancel 1x. Okay. So this is equal to 1 minus 2 ln of x over x to the power of 3. Okay. Let's look at part C. Now part C, you see that we have y is equal to ln of x squared plus 1. So this is not x, so we cannot directly use the formula that we just studied. So now what do we do? Here, this is where we have to break this function into two parts. And then we can use chain rule. So we can say that, okay, whatever in this ln, we're going to let it equal to u. So y is equal to ln of u. And then u is equal to x squared plus 1. Okay. Now, according to chain rule, right, if you want to differentiate y with respect to x, you can do it in two steps. You differentiate y with respect to u first, and then you differentiate u with respect to x. You differentiate y with respect to u, so you just differentiate ln of u. And then the second term, you differentiate x squared plus 1 with respect to x. Okay? And then we multiply. Okay? So for the first derivative, differentiate ln of u with respect to u. We can use the formula that we we just study, right? So instead of x, we have u. Okay, so then if we differentiate, you get 1 over u. And then for the second derivative, you differentiate x squared, you get 2x. Differentiate 1, you get 0. Okay, so you get 2x over u. And last step, you can change u in terms of x, where u is equal to x squared plus 1. Okay, that would be the answer. Okay. So in general, right, if you have ln of x, then you differentiate, you get 1 over x. But if it's something more complicated, for example, you have to differentiate ln of u, where u is some function of x, and you want to differentiate this function with respect to x. You can apply chain rule, so differentiate ln of u with respect to u first, you get 1 over u. And then you have to differentiate the u, which is whatever in the ln with respect to x. So that's the second half of this formula. Okay. Now let's go to the next functions that we are interested in. That is exponential functions. So what is exponential function? So the function that we're going to look at is something like this, e to the power of x. Now again, e is a constant. It's just like pi, and it's the same e, which is the base of the log that we looked at earlier. Now you see that the x, which is the input to the function, is in the power, or it's in the exponent. So that's why we call this exponential functions. Okay. So if we differentiate exponential function, or e to the x, with respect to x, the answer is e to the x. Okay, so we get the same function back. Okay, and again, you have to memorize this, so we can use this in the formula, in the problem. Okay, and one more thing, what if it's not e to the x, but it's e to some function of x? So let u be some, more complicated function of x. So we want to differentiate e to the u with respect to x. Again, you can use chain rule. So you differentiate e to the u with respect to u first, you get e to the u. Same thing back. And then the second half, you have to differentiate u, or whatever in the power, with respect to x. Okay. So let's see some problems here. Let's look at part A. Part A, we have x divided by e to the power of x. You see that both of these are function of x, so we have to use quotient rule. So to differentiate this, the top term is the high term, the bottom term is the whole term. Okay. So part A, the derivative is equal to whole dip high minus high dip whole over whole. Okay. So whole is e to the x, dip high, differentiate x, you get 1 minus high is x, differentiate whole, so differentiate e to the x, we get the same function back, over whole, so e to the x to the power of 2. Okay. Now you see that we can reduce this answer down by factor out e to the x and cancel 1 e to the x on the bottom. Okay. So the final answer is 1 minus x divided by e to the x. Okay. So let's look at part B. So to look at part B, function y is equal to x multiplied with 1 plus e to the x squared plus 1. So this is exponential functions where the power is not x, but it's x squared plus 1. Okay, so how do we do this? Okay, you can, if you look at the big pictures of these functions, you see that we got x multiplied with some other function of x. So we can apply product rule. Okay. So product rule says the first function is high. The function in the back, this whole thing is the whole. Okay. So part B, y prime is equal to, we apply product rule again, start with whole dip high plus high dip whole. Okay. So whole is the whole function in the back, 1 plus e to the power of x squared plus 1. Differentiate high, so differentiate x, we get 1. Okay. Plus high is the x, differentiate whole. That means differentiate this whole thing, right? Okay. So we need to differentiate 1 plus e to the power of x squared plus 1. Okay. So what's left is this differentiations which need to be worked out. So differentiate 1, you get 0. Plus differentiate this, you can think of uh, the power right here as a u. So it's e to the u. You differentiate e to the u, you get the same thing back, which is e to the u. Multiply, you have to differentiate the u. That means you have to differentiate x squared plus 1 with respect to x. Now, if you differentiate the last term, you get 2x. Okay, I think we got everything. So we got 1 plus e to the x squared plus 1 from the first factor. Then plus, we get x multiply with e to the x squared plus 1 multiply with 2x. Okay. If you multiply uh, the factor in the back, then we got 2x squared multiplied with e to the x squared plus 1. That would be our answer. Okay. Okay, last problem, problem C. If you look at C, we got y equal to e squared e to the x ln of x plus ln of 3. So we can differentiate each term separately because they are all connecting with the plus sign. So let's take a look at the first one. Differentiate e to the 2. And you look at this. So what is this? This is actually a constant because there's no x anywhere, right? Remember, e is a constant. So it's some number raised to power 2. So this is number. So you differentiate this, you get 0. Okay. So I'm going to write my answer right here. Differentiate e squared, you get 0. Differentiate e to the x, you get e to the x. Okay, that's what we learned earlier. Differentiate ln of x, it's 1 over x. And then we learned that in the beginning of the lecture. Plus, last one, differentiate ln of 3. Again, this is a constant because there's no x anywhere, right? You can use calculator to find this value. So differentiate a constant, you get another 0. So the answer is e to the x plus 1 over x for part C.